Hello everyone, welcome to another video. So today we'll be starting with the new chapter, determinants. So first of all, what is a determinant? A determinant is a property of a square matrix, right? It is a number that is associated with a square matrix, right? So we'll be discussing how to find out what this number is. And first of all, let's see what are the representation for a determinant, right? So if you're having a matrix A like this, right, let it have some elements like this, A, B, C, D. Then for representation of determinant, we'll be writing it as determinant A like this. Okay, this should not be read like modulus of A. This is determinant of A, and while writing the elements, we'll be writing like this, right? Like this it should be there. And also you can represent it like DET for representation determinant A, or a triangle like delta. These are representations of determinant of A, and only square matrices they can have a determinant. Only square matrix have this property, and this number how to find out we'll be discussing in the next part. So first let's see how to find the determinant of a first order matrix, right? First order matrix means it should be having the order 1 by 1 because this is a square matrix, right? So square matrix of first order 1 means 1 by 1 order, right? So it has only one element. So the determinant of this matrix, let's assume it to be A. So determinant of A matrix will be equal to the element inside, that is the element A here, small a, right? So for example, if we have a matrix B such that 7, the element 7 inside, so what will be its determinant? Determinant of B will be the number 7 itself. Whatever it's there inside, that will be the determinant of an order 1 square matrix, right? Now let's see for an order 2 square matrix. So order 2 means it is of the order 2 by 2, right? So let's assume it has the element A11. Why 11? Because first row and first column. A12 first row but second column. A21 second row but first column, and A22 and second row and second column, right? So for determinant, how to do this means we have to do it in this order with a negative symbol in between, right? Multiply the first element with the last element, okay, in the diagonal order. A11 times A22 minus A21 times A12. So this will be the determinant of a second order matrix. The symbol in between has to be minus, and you have to multiply the primary diagonal minus the second diagonal in this order, right? So like this you can find the order of a second order matrix. So let's do some questions related to the determinant of a 2 by 2 order, right? So first question, we are having this matrix and we have to find the determinant, right? So first we have to do it in this order, right? And negative symbol in between. So first element with the fourth element, first primary diagonal, 2 times 2 negative, right, that is minus, then minus 1 times 4, right? Now do the multiplication. 2 times 2 would be 4, and minus minus would be plus, right? So plus 4 times 1 would be 4, and it would be 8. So the determinant of this matrix is 8, right? So let's go to the second question. So we have to find the determinant here also. Now same process here, but instead we are having variables here. So the first element with the fourth element, x times x, right? X into x, then minus x minus 1 times x plus 1. Now do the multiplication. X into x is x squared minus, here we are having the property, right? A plus b into a minus b is a square minus b squared, right? So here instead of a we are having x, right? And instead of b we are having 1 square, and in between it should be a negative symbol. So now we have to take the minus inside the bracket. So x squared minus times plus would be minus x squared, and minus times minus would be plus. 1 square is 1 itself, so x square and x square would cancel, so the determinant is 1. So now we are having a question here. First determinant, it's actually equal to the second determinant. Here you should not get confused or misguided, because here both they are comparing the determinants, not the matrices, right? So first you have to find the determinant, then only you can find the value of x, right? Not directly compare the x. If you directly compare, you will get x is equal to 2 and x is equal to 4. So x will be having two different answers. So that will be totally wrong. Here you have to find out the determinant, then you have to compare both the matrices, right? So first let's do the determinant on both sides. 3 times 1, you have to do like this, right? 3 times 1 would be 3 minus x times x would be x squared, and this has to be equal to, right, 3 times 1 would be 3 minus 4 times 2 would be 8. So now you can do like this. 3 minus x squared is equal to 3 minus 8, it would be minus 5. Then what you have to do, you can take the minus x squared this side, so 3 will be equal to x squared minus 5. Now taking the minus 5 to the other side, x squared is equal to 3 plus 5, it will be equal to 8. So x squared is equal to 8. Then you have to find out the square root of 8 to find the value of x, right? X can have both positive and negative value, right? X is equal to plus or minus root 8. You can actually simplify this root 8, right? If you check here, 8 can be written as 2 into 2 into 2. So if you check here, we have 3 2's, but for square root we need 2 2's to convert it into 1 2 outside the bracket, right? Outside the square root symbol. So it will be equal to 2 2's inside will be taken as 1 2 outside times root 2. Only 1 root 2 will be inside, right? Then plus or minus symbol. So x will be equal to plus or minus 2 root 2.